Could you please introduce yourself and talk about the Topological Materials Summer School?
My name is Nai-Chang Yeh. I'm a professor of physics at California Institute of Technology, United States, and I'm also a co-director of the Kavli Nanoscience Institute at Caltech. And so I came to Etop to participate in this summer school on topological matter. A little bit about my own research. I work in condensed matter physics research, which is about physical properties and interactions of materials. And so it encompasses a wide range of topics. And so in condensed matter physics, I primarily worked on things called strongly correlated electronic materials and also topological materials. That's the theme of this summer school. And so I am an experimentalist, and so I use different experimental techniques to study the topics I mentioned. And the topics also include a wide range of interesting materials like superconductors, magnetic materials, spintronics, they're spin-dependent electronics, and a lot of low-temperature physics topics, and of course, topological materials.
And this summer school, I suppose, this subject being so new and so promising, and I don't know if there are many people interested in this subject in the world or not, but obviously it's very important. It's being in Turkey, and it's an international summer school, and I'm sure there are so many people who are getting. It's very intense school. Maybe you should talk about that. It's very intense. 10 days of non-stop from 9 till 10, or
9 till 9:30. Yeah, effectively. Yeah, more than 12 hours a day. Well, there of course there are breaks in the middle, but yeah, the summer school is. Starts from 9 o'clock in the morning, 3 hours of lectures until lunchtime, with a half an hour break in between, but there are 3 hours total of lectures in the morning. And then after the lunch break from 12:30 to 1:30, then there will be another 3 hours of lectures. So during a day, there are 6 hours of lectures. And then in the afternoon, there's a break for students after they are totally exhausted and when the heat is on. And so they could go swimming or walking a little bit. Then around 6:30, there will be half an hour short seminars given by young students to talk about their research from 6:30 to 7 p.m. And then 7 to 8 is a 1 hour dinner break. Then from 8 o'clock till 9:30, students would get together with lecturers, and they could be given some problems, try to solve the problems, or they could ask the lecturers questions. And so the program is very intense.
And I'm sure they are getting a lot out of it.
I hope so.
Yeah. I mean, what would you like to say about this kind of summer schools internationally, where they stand and how important they are? And
I would say that Etop is a unique place in Turkey, or pretty much in this probably Balkan area. It's a very special institute that arranges these summer schools to help to really educate young researchers, young students. These international schools, and often they come together with conferences sometimes. Sometimes it's not just a summer school. Like 2 years ago, 2 years in a row, 2 years ago and last year both, I actually helped arrange first a summer school, and after the summer school we prepare students with knowledge of frontier topics. Then follow that, there will be a conference. And then we would invite top-notch international researchers to come and give talks about their updated research. And so the summer school itself will prepare students with the frontier knowledge. and then follow that. Sometimes it follows with a conference, so they could really interact with top researchers from all over the world. And so Etop actually provides this opportunity to bring together lecturers from all over the world who are doing frontier research in whatever topics that the school is about. And then students can have the opportunity of learning these topics from the lecturers. And also this provides an opportunity for young students to work together and also to interact with researchers from all over the world. It's a very nice setting, I believe, for young students. And I think students who have come to the summer schools, at least I have heard very, very good things from the students. They felt they learned a lot. And also sometimes it does create opportunities for students. I know that 3 years ago, I actually invited Professor Brian Maple from University of California, San Diego. He is a very well-known physicist. He came and gave lectures, and then 3 years ago, he was here 3 years ago and also 2 years ago. And then he interacted with students, and one of the students in their summer school, then after she graduated, she went to UC San Diego to become his postdoc. And then she is doing great there in UC San Diego. And I myself, I have experiences that one of the summer school students then applied through the Turkish government program to become an exchange student at Caltech. And so she spent about 9 months at Caltech. And I think she also felt it was a very good experience. But basically, these are just examples in addition to the lectures students learn. They also have human contact, they have interactions. And also, I know for a fact, lots of the young students and postdocs, researchers here, after they came to the summer school, they became very good friends. And it's very good for their professional life, career in the future also, because they know people in their fields and through this kind of very good interaction.
Yeah, that's right. You are an experimentalist, and to be experimentalist requires, I think, so much. You have to bring so many elements together. Mm-hmm. You need money, you need theory coming to it, big institutions for it. So what kind of work you have to do for it?
To be an experimentalist, it takes a lot of work. Takes a lot of work and takes very little sleep because you have to work so much that you don't get much sleep. If I talk about what I have to do as an experimentalist, at least in the United States, of course, then a lot of the experiments can be very expensive, and so we have to apply for grants to purchase equipment and to support our students and postdocs in our research group. And I am from Caltech, California Institute of Technology, and that's a private institution. And so actually about 65% of the entire institute operation is actually on the overhead generated out of the government grants professors bring in. And so there's a huge overhead we have to pay. It's 66.5%. So what that means is that if I need $1,000 to pay for my experiments, then I need to find $1,665 so that I give the $665 to Caltech and I keep the $1,000 to do whatever I need. And so it gets very, very expensive. Also, unlike in many countries of the world, we also have to pay for the tuition that students, if we hire a graduate students, we have to pay for the tuition of the students. Professors have to pay for that. So we have to pay for the tuition, pay for the salary, pay for the benefits, and then pay a huge overhead. And so that's all we have to pay. So it's very expensive to support students. It's also very expensive to support postdocs. Although for postdocs we don't have to pay tuition, but still we have to pay for the overhead on top of the salary. We have to pay benefits and overhead on top of benefits. So everything we do, it's very expensive. So the number one thing is that we have to find money.
Yeah.
We have to find money in order to do research. Without money, it's all over, right? And so it's a very competitive thing. In the United States, even if you're very well established, it doesn't matter. The research grants, you can only compete for research grants, and research grants are only given if you have a good proposal and also if you have excellent track records, and also you have to be doing up-to-date research. And so even for people who have become members of National Academy, if they're not productive for a few years, they may not get their grants. And so it's very, very tough. So we are like, it keeps us on our toes that we have to be constantly working hard in order to get our next grants to keep our research going. Yeah, that's the sad part of it, but this also keeps people to be very competitive, meaning in the way that they have to really do their best all the time. They cannot be complacent thinking that, okay, I'm already well known and I have accomplished a lot in the past. It doesn't matter. People ask whether you're accomplishing a lot now in order to get grants. And so people have to be productive and hardworking all the time. So getting money is number one thing. Then, of course, we have to set up, we have to do the research. And in order to do frontier research, you have to keep your knowledge at the frontier. So it's not like, okay, you have a PhD and then what you have done in your PhD, you just keep doing little modification of that. No. In condensed matter physics, every few years there will be a big breakthrough and there will be another big breakthrough. And these big breakthroughs, if they happen, then, well, first of all, you want to be one of those who make big breakthroughs. But if there are new fields that are created because of these breakthroughs, then you have to quickly adapt to it if you want to do something interesting there. So you have to keep your knowledge fresh. And so that's another thing. You have to keep learning and keep being creative in order to do frontier research. Then, of course, we have to teach. We have to find money. We have to learn frontier things, and we have to create frontier things, and we have to teach. And then we have many, many other duties, because once you are more established, you're asked to do all kinds of things. Like right now, I'm a co-director for the Kavli Nanoscience Institute at Caltech. That means I have these duties. I have to look after a major institute that consists of cutting-edge nanofabrication and nanocharacterization tools. I have to keep that thing going. I have to make sure that facility runs well, and then we can be an intellectual hub for nano research. And so that's okay within the university, and often we are asked to do all kinds of things. At Caltech, professors, we have to. We are the people who decide how the institute should be run. And so we have to be actively involved in many things. So we have institutional duties, and then we got called upon by all kinds of national science foundations, all kinds of funding agencies, organizations to serve on panels or reviews, and we have to review papers, proposals, and we have to review prizes and then international activities. So it goes all the way up. So we have to be super beings. We have to constantly be working.
Yeah. Yes, you have to. I mean, how can you do it?
Just don't think about. The idea is, don't think about how much more you haven't done. Just try to be happy to say, okay, I've done a lot, and then just keep going, not worrying about what cannot be done or what has not been done. Yeah.
I mean, would you say that a country without doing basic science, could they develop applications, technologies, and so on? I mean, how? I mean, I suppose it's very important to do basic science to develop anything, you know.
Yeah, I would say that if you look at all these technologically most advanced nations right now, all of them have pretty strong basic science programs, because you cannot develop technology out of nothing. It just doesn't happen. It's like, I will use this metaphor, you have to grow the tree, and the tree, you have to nurture the tree, and eventually the tree will bear fruits. And the fruits may be what you see as technology, but I would say the tree and the roots, those parts are fundamental science. I don't think any country can be great at technology without excellent fundamental science. Period. That's my opinion.
Yeah. And would you say nowadays, I mean, there are certain countries are really now getting stronger in basic science. And those are the countries also we think that they are getting good in technology.
That's right.
You going around the world and witnessing all these things, would you give us some examples about that?
Yeah, I can give, regarding the some rising power in the world, and in terms of their investments into science, I can give you examples like, if you look at China. China now, I would consider that, I think maybe another few years from now on, I would say that there might be two superpowers in the world. One is the US, the other would be China. China is fast developing, and so you look at their GDP, and you look at the economy, and you look at the money they generated. They're incredible. And they're also becoming very good at technology. But one thing they know to do, they're investing a huge amount of money into fundamental science, because they understand that the fact that U.S. could be strong in technology was that U.S. started with very strong scientific programs. And China is doing exactly that. Not only that, they're very, very aggressively recruiting talents from overseas, especially their homegrown talents that went out to U.S., to Europe to study. They try to attract these talents back with excellent support. So much support that it makes U.S. professors very jealous. They would just attract people with effectively millions of U.S. dollars to help them to start up labs for each group. For each talent they try to attract back, they're putting millions to build the infrastructure and for the person to hire the top-notch people that he or she could. And they are doing that. Like right now they have a 1,000 people, 1,000 talents programs. I don't remember exactly what that's called in English translation. But they're actively recruiting 1,000 senior people from overseas back to China. And giving them enormous amount of support. Similarly, they're also trying to recruit 1,000 younger rising stars, also from abroad, and coming back to China, and also give them excellent support. And so they understand this concept, and they're putting a lot of money into it. And looking at that, actually, we try to tell U.S. government now, look at this, you're not putting enough money compared with what China is doing. And so that's one example. Another example, if you look at Korea. Korea in recent years has become very strong in their economy. And they are also trying to put concentrated big sum of money. Of course, Korea is not as big as China, but so they try to concentrate money into specific scientific programs in order to strengthen certain programs. And these are all basic science programs. not mandated research. I would say that if you look around if you look at history, human history, look at all these major technological breakthroughs or conceptual breakthroughs, most of them came out of completely independent people. They're not from any mandated research. Yes, mandated research can be useful for making steady progress in certain areas that may be uniquely important to national security or to health or to certain things. Yes, you can have mandated programs to bring in talents to and to strengthen that area. But you should also keep a nurturing ground for creative seeds to blossom. And if you don't have that nurturing ground, actually more than 90% of all of the breakthroughs would not have even happened. Most of the breakthroughs, most of the Nobel Prizes, for instance, they were awarded, I'm talking about the physics, chemistry, biology, medicine, these prizes. Most of those actually came out of independent researchers. Researchers there, I shouldn't say independent, individual researchers, not special government big programs. And so I think a healthy scientific environment should be that you should have nurturing ground for creative minds, and you should provide that. And at the same time, you could put some money into targeted, mandated research that may be useful for special needs that you need to make quick development. But the thing is, what's a breakthrough? A breakthrough is breaking away from anything else you could have ever imagined. So if something is mandated, by definition, it cannot possibly be a breakthrough, right?
So Etop is quite unique. It's not just making the summer schools. Maybe if you could, you have been witnessing Etop's development.
Yes.
Through it has been few years you have been seeing what's happening, and Etop has got so many different aspects. Could you tell us about your involvement and what you think about Etop?
I think Etop is a very unique organization that it's not just for Turkey, but also in the Balkan area, in this general area. It's one of a kind, a special institute that really provides important scientific education programs and also bring together good scientists for them to interact. That helps to advance sciences and to advance international scientific collaborations. And so it's a very, very unique institute. But unfortunately, it's a private institute. And so it doesn't, because in Turkey, I think there are no rules that would allow government to provide direct support for a private institution like Etop. So the operation of Etop has been entirely, and the finances have to rely on the director, Professor Hakioku, to raise money by writing all kinds of grant proposals and then try to also run education programs by getting money from parents, and so that he could create these education programs for young students and so on and so forth. So it has been a struggle. It's a tough situation to keep the institute going. I have been with the institute. This is the 5th year for me to come to Etop, and so right in the beginning, it was the first time I came was when Professor Hakioku invited me to come and lecture at a summer school. So I came to lecture condensed matter physics, quantum field theory for condensed matter physics. I actually lectured 60 hours, 60 hours, over 12 days, 5 hours a day. It was very intense. But students also work extremely hard because they couldn't get these kinds of lectures in Turkey, and so I also provided them hundreds of pages of class notes. And so even though they couldn't digest all those things in that short period of time, the notes were helpful for them to go back and study. And when I visited, then I then Turo, the director, then he discussed with me about his vision. He would like to bring together more international participations and to have more opportunities for Turkish students and also for students in this general Balkan area. And so I have connections with Asian Pacific Center for Theoretical Physics. And so with that, the following year, I helped run workshops, and I invited some very prominent people, actually, to come and lecture. So each of them lectured for 10 hours for students. And then after that, we started running a joint conference and summer school with Asian Pacific Center for Theoretical Physics. And that's the home base of that is in Korea, but it actually consists of membership countries of all these Pacific Rim Asian countries like China, Taiwan, Korea, Japan, Singapore, Hong Kong, those countries. And so then we started running these international programs, and so 2 years of conferences, and this year the conference rotated to Korea. But in addition, I invited various international visitors, and so I also helped with establishing basically affiliations between Etop and Institute of Physics, Chinese Academy of Sciences, and also Academia Sinica in Taiwan. And Turo himself actually has been able to also make connections to multiple other major prominent institutions. And so all these are wonderful activities, and it really makes Etop very visible internationally. But ironically, despite all of the great success stories, still the finances for Etop have been something that the director will have to worry on a yearly basis, which is a pity, because an organization such as Etop would be nice if it can be well supported, because it enhances the visibility of a Turkish institution, and it educates Turkish students, provide opportunities for them to interact with international top researchers and students. So, and this is a beautiful setting also. So it's a wonderful setting that people like to come and see the beauty of Turkey. And so I think I really wish that there would be ways that can have better long-term financial, longer term, not extremely long-term, but longer-term financial stability for an institute like Etop.
It needs appreciation, doesn't it?
Right.
Thank you. Thank you very much.